Good afternoon. Here's the truth. The truth is that the people who run most businesses today are scared. You know what they're scared of? You. They're scared of you. They're scared of you because you can write code. They're scared of you because people who can write code are driving this thing called digital transformation. Think about this. In retail today, who's the most important retailer in the world? Is it Walmart? No, it's Amazon. Come on, it's clearly Amazon. Highest market capitalization, it's Amazon. In automobiles, companies like Volkswagen and BMW and GM and Toyota are very important, but in automotive today, what's the most important trend? Almost certainly, it's self-driving cars. The leader in that trend is who? Oh yeah, it's Google, right? Or think about this, transportation. What's the most valuable transportation company today? Well, Uber is still private, but their estimated valuation exceeds that of Delta Airlines. Or even things like home automation, where companies like Nest, now owned by Google, are becoming so important. What do all of these have in common? All of them have in common the reality that their value is derived from software. Digital transformation means that software does more and more and more and potentially upends industries. This is why the people who run businesses are afraid of you. Because you have the power, potentially, to completely disrupt what they do, how they make money. Now, why is this? Why is this? Is it because software guys like us have become massively smarter in the last few years and can now do all kinds of cool things because we're just so much better than we used to be? No. I wish that were true. There's some truth in that. There are ways in which we're much better. Deep learning algorithms, for example, have gotten much better. So there are ways in which we've gotten better. But fundamentally, the thing that really drives this transformation, that underlies the very rational fear of these business leaders, isn't us, at least not directly. It's Moore's Law. It's Moore's Law. Now, you all know this picture, right? Here's 45 years of Moore's Law. Every 2 years, approximately, what you can buy for computing power for the same money doubles. Moore's Law stated in a common way. So you know this, right? We've all seen these diagrams. We've all seen Moore's Law increasing. Great. But you know what? This picture is a complete lie. This picture is utterly, utterly misleading. If the folks who run businesses look at this picture and think they understand Moore's Law, they could not be more wrong. Here's why. It's linear, right? The picture is linear. But Moore's Law means that things double every 2 years. This diagram is linear only because the vertical axis is logarithmic. The real diagram of 45 years of Moore's Law, it looks like this. Here's 2010, here's today. We need to get this in our bones. Because think about this. This is the growth in the last half dozen years. It is so large that all the growth in the previous, 30 years or so, barely shows up on the graph. That's how large the growth is. When something doubles every 2 years, it means that we make as much progress every 2 years in computing power as was made in the entire history of computing up to that time. The growth is astonishing. This is why people are scared. Mark Andreessen famously says, software is eating the world. He is right. And he's right in part because, yes, we're all smart people, great, but he's really right because of this. Because Moore's Law makes it possible to do massively new things. Things that were impossible a few years ago are easy today. Like what? Like speech recognition. Good example. 5 years ago, it was not very good. Today, it's terrific. Again, we've gotten better at it, but really, we've just gotten way more transistors to use. And imagine 5 years from now. Things that are hard today will be easy. Software is eating the world. Andreessen is exactly right. And it's doing it in no small part because of Moore's law. To understand what exponential growth really means is to have the feeling you have to appreciate the magnitude of change that we're seeing. And so, we have a responsibility here. Because think about it, hardware without software is worthless. That makes us really important. And as Moore's law grows and grows and grows, we'll get more important and more important and more important still. So let me tell you, you get back to work tomorrow, you should all ask for a raise. Very important. Because you are so important. I'm only half kidding, right? But here's the thing. We have this responsibility. We do. And so, in essence, it means that we must be worthy. We must be worthy of this responsibility that we're being given. You know, how many engineers made Moore's law real in the last 45 years? How many? Would you guess on the order of maybe 10,000 or tens of thousands, something like that? Those people were among the most important people in human history because they made such a huge change in our world. But so are we, because without us, their work is meaningless. And so we have this responsibility. We must be worthy. We have to get better innovation because that's what this is all about fundamentally. And what that means is that we have to reset our defaults, the way we naturally do things. We've talked in this conference about three giant areas, three big themes that I want to hit on again today and summarize as this closing keynote. They are defaults we have to reset in cloud, in DevOps, in open source. I'm going to discuss all those and the default resets we have to do. Before I do, however, let's talk about innovation. Here's what I find. I find that people often don't think terribly clearly about innovation. And given the awesome responsibility that sits upon us as software professionals, it is incumbent upon us to do this. And so, here's how I like to think about innovation. To me, it's useful to view innovation through the lens of what I want to call the I3 model. Innovation starts with an idea. You've got some new concept. Innovation then continues with the implementation, making that concept real, making it usable. But you're not done yet, because there's one more I. The third thing you have to do after idea and implementation is infusion. To get folks to actually use the implementation, you must change people. Innovation, idea, implementation, infusion. The I3 model. A couple of comments about that. Ideas are really overrated. People often confuse innovation with ideas. That's just nuts. Ideas are overrated. The second two I's matter at least as much, if not more. And often, the three I's are done by different organizations. Think about this. Think about the rise, the spread of graphical user interfaces, GUIs. Who had the idea? Well, Xerox PARC back in the 70s. Right? Who got the implementation right? Sure, it wasn't Xerox. They built it, but it was not usable. The implementation was gotten correct by who? By Apple. The Macintosh, yes? 84? But then who really made GUIs ubiquitous? Who got infusion right? Not Apple. They were this niche product for a long time. It was Microsoft. Windows 95 especially, that made GUIs ubiquitous. All three of those phases happened with different companies. That's not so uncommon. A more recent example is Hadoop, where the idea of Hadoop came from Google in the MapReduce paper. The implementation of open source Hadoop was done at Yahoo, and the infusion was done by people like Hortonworks and Cloudera and now Microsoft in making those things available in Azure. So the point is, these three phases all matter. They're often done by different organizations, and you don't have innovation until you've gone through all three of them. And one more thing. It's infusion, not diffusion. If you are a fan of innovation, a student of the topic, you know that there's a famous book called The Diffusion of Innovation. Well, it's kind of misleading because diffusion is a passive process, isn't it? The oil diffused in the water. Innovation is not like that. People don't like to change. You have to push them typically. Infusion is an active process. That's why it's infusion, not diffusion. It's also infusion because infusion starts with an I. And I couldn't have an i3 model if it was called diffusion. Wouldn't fit the same, right? So, all right. There are, of course, connections among innovations. The output of one i3 process becomes input to another. And often, many i3s are input to a single new i3, and so on. There are lots of these connections, right? That's the process of innovation. Thinking about IT innovation, our focus, there are a couple of connections that matter a lot. So, there's an important relationship between two kinds of IT innovators. IT creators, those organizations that create new technology, are one category. Microsoft, IBM, Oracle, open source projects, firms that create new IT technologies. The second category is IT user organizations, banks, insurance companies, governments, retailers. Most of you work for IT user organizations. These two groups each have their own separate i3 processes that they go through. And they are connected. They are connected. It looks like this. An IT creator has a technology idea. Microsoft, for example, might say, let's add a new feature to SharePoint. Let's build a public cloud platform like Azure. They have technology ideas, which they implement and then infuse. Infusion for Microsoft means things like getting you to use it. Because what's coming out of them is a technology, a new technology, which becomes input to the i3 process of an IT user organization like yours. But you are trying to have not a technology idea, but rather a business idea. You want to find a way in which this new technology can improve what your organization does. You then implement that idea and infuse it into your own company, your customers, whatever. The end result is value. I would argue strongly that unless there's value, it's not an innovation. Nothing counts as innovation through this entire process. Otherwise, it's just an experiment. Be careful about that, because the word innovation has so much power that people will use it for things that are really just experiments that are going to fail. Innovation happens only once this is all done. There's actual value. So I find this a useful way to think about what we do, the innovation we try to create. Because really, every custom app that you create in your organization, in your private life, is an innovation, isn't it? Isn't it? If it's not, if what you're building is like many other things that are out there, stop building and buy the software. You should buy things that aren't actually innovative. Right? So every custom app is always an innovation. That means that you, once again, are the engine of innovation today. And it also means that exploiting innovation requires resetting your defaults. What I mean by that is the way you naturally do something without thinking about it. The usual approach is your default. If you get some cool new thing that you could do differently, but you do it only one every 10 times, not much value. You really get value from new innovations when you reset to make those your default mode of operation. And so, let's talk about default resets that reflect the themes of this conference. And let's start with cloud. What do you think were the most important events in enterprise IT in the last dozen years or so? We might disagree. There's lots of possible answers. But I believe that it's possible to point to three distinct events that were the most important things that happened for enterprise IT in the last dozen years. Here's what they are. Number one, in 2004, the IPO of Salesforce.com. Why? Because Salesforce was the first company that showed us that software as a service, SaaS, worked as a technology and as a business. And today, its founder, Mark Benioff, is a billionaire. They did something right. The second event, much quieter, much harder to see at the time. It was the launch of Amazon Web Services in 2006, because that's what gave the world public cloud platforms. The third event? Not quite at all. The third event was probably the single most hyped event in IT history. It was the launch of the iPhone. Because the iPhone is what gave us mobile as a platform, not just phones to call, computers in our pockets to write apps for. Those three events, I would argue, were so important for enterprise IT because they have changed the default enterprise IT platform. Traditionally, as we all know, it looked like this. Clients were PCs and laptops. We all had data centers with infrastructure, servers, and all that stuff. On that infrastructure, we ran packaged apps that we purchased. We ran custom apps that we built. That's the classic world, which I'm sure most of you have currently in your environment. But the three events I just talked about have changed that default. It is no longer this. The environment for new applications is now this. Clients are more diverse, obviously. PCs, laptops, tablets, phones. Rather than deploying in our own data centers packaged applications, increasingly, overwhelmingly, people choose SaaS apps instead in the cloud. And rather than building new custom apps in our own data centers, increasingly, the new default is public cloud platforms. Those three events were so important because they drove this change. The iPhone drove the client change. Salesforce IPO drove the SaaS change. Amazon drove the public cloud platform change. Think about this. All three of those events came from who? Well, not Microsoft, right? Not IBM, not HP, not VMware, not Oracle. No classic enterprise vendor. They all came from the outside world. That's so typical. This kind of innovation rarely comes from the incumbent players. It's from somebody else. So no surprise there. But this, I would argue strongly, is the new default for how we buy, how we use, how we build applications in organizations going forward. Startups today all do just this. Established organizations, like most of you, have a more complex world. They have this hybrid structure with on-premises and cloud coexisting. Right? We'll have that for a good long time, many of us, maybe indefinitely in some instances. But more and more, the new applications will be built on cloud platforms or purchased as SaaS. Now, what stands in the way of everything in the public cloud? Still, I would argue, the biggest barrier remains this notion of trust. People have a hard time with this. And I got to stop right here and talk about this for a minute. I've given a lot of talks on public cloud technology. And it used to be that I would say things like this. I would say, you got to build trust. I understand. It seems scary, use public cloud. And so the right thing to do is to start small and see if it works, right? You got to build trust. But you know what? I've stopped saying that, and here's why. First, we're pretty far into this cloud thing. And so they've done a pretty good job. Microsoft, Amazon, Google, the cloud people, done a pretty good job of security. But here's the real issue. The real issue is if you think that your own data center is more secure than Microsoft's Azure data center or Amazon's or Google's, you are almost certainly wrong. Almost certainly wrong. I live in the US, where, as you might know, there's this election going on. You've heard about it a little bit, possibly? The Democratic National Committee had their email hacked a while ago. If that email had been in, say, Outlook.com or Gmail, would it have been hacked? Not so clear. And more, the hackers were contending with appear to be not just a bunch of malcontents in a basement somewhere, but national governments. They're national governments. And so you want to put your IT guys against a national government? Your guys might be great, but still, it's like calling out your police force to defend against an army's invasion. Trusting, which is what we have to do here, trusting Microsoft, Amazon, Google, to have more resources, more focus, more motivation, to me, seems wholly irrational. The belief that your data center is more secure than those run by the big cloud players, I believe, is just wrong. It's just wrong. Still, there are lots of computing options. You might choose to run things in the public cloud. You might not. You might use a hoster. Let's call them hosted public cloud service providers. You might, of course, still run things on premises, obviously. In the cloud technology space, using public cloud in the context of this event means using Azure, Microsoft Azure. Going forward, it's in preview right now, you can also run Azure services in service providers or on premises with the software called Azure Stack. Azure Stack can run in both those places, providing a subset of the global Azure services. Here's what you get in the first release. It has virtual machines, the IaaS technology. It has some of the core storage things, blobs and tables and queues. It has networking stuff. It has the two core PaaS technologies, App Service and Service Fabric. It's got some security stuff. Azure Stack also includes ARM, Azure Resource Manager, which lets you automate deployment of VMs and apps and so on, along with its own portal, which looks much like the big Azure portal, and support for other access. So that's the first release of Azure Stack. Azure Stack is shipped initially bundled with hardware. You buy it as a box. And the reason for that is that making Azure Stack work on a well-defined control set of hardware is challenging enough. To make Azure Stack work on arbitrary hardware, tough. They might do it someday, but the first release doesn't do that. The first release says you must run it on this defined hardware you buy with it. Okay. So why do you want to use Azure Stack? Well, you can have the same cloud services everywhere. On-prem, service provider, global cloud, and they are the same. Azure Stack is a subset of full Azure, which means your code, your data, your skills are all portable across all of those areas. And as I mentioned, it's an appliance. It's straightforward setup. People who've tried to build private clouds in the last few years have had, let's call it mixed success. Not just Microsoft technologies, everyone trying to do it had mixed success. And the enemy is always complexity. It's tough to get this stuff to work. And so by shipping Azure Stack as an appliance on this predefined hardware, what they're trying to do is make that more tractable, make it easier to install and get running and use your own private cloud. So I promised you default resets. The default reset I would suggest here is the following. It is to recognize that going forward, all new apps are cloud apps. Now, they aren't always public cloud apps, but they use these core cloud technologies. For this default reset, that's the idea. What's the implementation? What do you have to do to make this real? Well, you've got to use the technologies. You've got to use things like App Service and Azure Functions and DocDB and whatever else. If you want private cloud approaches, and you're in the Azure world, then you'll use Azure Stack, deploy Azure Stack. What's the infusion? Infusion, remember, means changing how people behave, changing people. And so infusion here, I would suggest, means things like this. It means that you use this traditional approach. You explore, what are these new technologies? What do I want to learn? What's interesting? You choose the ones you want, you learn them, you then use them, you then mentor others in using them. Explore, learn, use, mentor. That cycle. You also have to get real about trust. You have to internalize this notion and convince people who run your company of this notion that almost certainly, your data center is not as secure as the giant ones run by Microsoft, Amazon, Google, the big cloud players. What if you don't do this? Suppose you don't reset this default. What happens is this: you'll fall behind. This enormous change. I mean, come on. There's no debate anymore, is there? The cloud is the future. The cloud is the present for so many of us. There's just no debate. You'll also, I would argue, increase the odds of your apps being hacked because the cloud's more secure than you are. And, critically, you will limit your career because you won't have the right skills to move forward into your next role, your next job, your next employer. So, default resetting is important. The cloud default reset, I would suggest, looks like that. Default reset number 2, the move to DevOps. Let's go back to this notion again of a digital transformation, the buzzword du jour. What the heck does that mean? Well, it depends who you ask, but I would argue what it means is that software just does more and more and more and more. Software is eating the world, right? Applications stop being just support. They don't just do billing in the back office. Applications become the business. Think of Amazon. Think of a self-driving car. Applications are the business. Software is essential. And so to me, that's what it means to do digital transformation. That means also, Corey said this the other day, that every company becomes a software company. As software eats the world, as we get more important, every company must get good at being a software company. Among other things, that means that how well you create and deploy the custom apps that provide an organization unique differentiation gets really important. It gets really important. And so let's think about that. There are, I would suggest, 3 aspects of creating and running applications. There's governance, which means making decisions about applications. There's development, creating it, modifying it. And there's operations, running it. There's a picture I find useful here that shows these guys like this, and then realizes that just like people, applications have key events in their lives. For us, the key events are what? Well, birth, marriage, death. Actually, it's more like birth and marriage and marriage and marriage, in the modern world, I guess, but still. Applications also have core events. The idea, the first thought, let's build this app. Deployment, the first deployment is a core event. And the day the app is finally taken out of service, it's killed, is a core event. You can think about governance, development, and operations in terms of those events as lines. Governance, for example, is always happening. You're always making decisions about an app. What is the most important decision ever made about an application? Is it, what language to use? Is it what platform to build on? Or what database to use? No. By far, the most important choice, the biggest decision ever made about an application is whether to build it or not. The very first thing. It's a governance issue all the time. Then, in the classic waterfall world, which I'm sure none of you are using anymore, right? That was a joke, right? Because I'm sure lots of you are. It's hard to change. In the classic waterfall world, development starts with requirements, then does dev, then does test, then deploys. And once you deploy, once you release this app, operation starts. In classic waterfall, you then might take a break for a while, and then eventually do a new version of the app and release it. That's still how software development works in many organizations. We've learned, however, that there's a better way, at least in most scenarios. The better way is to do this. It's to do requirements, development, test over and over in short sprints, and then release what you have. In the first waves of Agile, we would do that, then take a break, then do it again later on and release. But now, there's an even better way. Now we've realized, especially when we're building cloud services, as we more and more are, that's our new default, right? I just told you that. As we build those things, it looks more like this. We do our initial sprints, we release what we have, then we just keep on going. We release things periodically when it makes business sense to do so. Every sprint, every third sprint, whatever. That's continuous delivery. But of course, doing that requires various changes, not just in technology, but in culture. Hence the rise of this notion of DevOps, which is the cultural change required to make that model work. But notice something else here. Notice that in my diagram, the pink rectangle representing DevOps is extended to include not just development and operations, but also governance. Well, why is that? Here's why. It's because governance is so often left out of DevOps conversations, and this is really wrong. It ought to be called not DevOps, but GovDevOps. Do you like that? No, it sounds terrible, doesn't it? But still, it's right. It is right. Because if you and your organization are able to convince the dev guys and the ops guys to go do this, but you haven't changed your governance, it's not going to work. Here's an example. Think about how funding works. In the classic model before continuous delivery, funding would match the chunks of development that you did. Big chunks of money for a project, then it stops for a while. The next version, big chunk of money, then it stops for a while. With DevOps, continuous delivery, you've got to have funding the whole time. The funding model for the app changes. So tell me, can DevOps ever succeed if it's not really GovDevOps? I would suggest no. I encourage you to be aware of this, because you require constant funding in that case. So why do DevOps? You probably know the answers. Makes the business happier. They can make changes faster. They can learn things faster. You know, as more organizations become effectively software companies because their core value comes from custom software, the ethos, the approach of software companies will spread. For example, this notion of minimum viable product, MVP, that is ubiquitous among software startups, is spreading more and more out of that pure software world into the wider world. It makes so much sense. You release your MVP, you get immediate feedback, you change it. To do that, you virtually have to have continuous delivery. Now, not every scenario makes that work. I'm flying back to San Francisco this week, and I hope that the jet I'm on doesn't have engines that are the manufacturer's minimum viable product. I would not like that. But in many scenarios, it's a fine thing to do. It's the right approach. And so the DevOps approach makes that doable. It makes developers happier, obviously. Your work gets used faster. And eventually, once they're over the shock, it makes ops guys happier too. Because now this scary thing of release that happens every year or 6 months and takes a weekend and is full of stress happens all the doggone time. And you get really good at it because it's routinized. It becomes totally routine. So how do you get to DevOps? Well, one way to view it is to say you start with tool change, which enables process change, which requires for success cultural change. So the tool change includes a range of things. One example of tool change is treating infrastructure as code. For example, if you're using Azure technologies, public cloud Azure, Azure Stack, I mentioned this earlier, they both support ARM. They both support Azure Resource Manager, which lets you automate deployment. You can create scripts to automate deployment. So, for example, Part of this might well be making sure you've got the exact same environment for dev and test and production. And if you do that by creating a script, an ARM template that deploys all three, life is good. An example, infrastructure as code, an example, by no means a complete example, but an example of tool change necessary for successful DevOps. The process change then looks something like this. In traditional releases, what do? The dev team gives this big new chunk of code to the ops team who makes it work on the system. In the DevOps world, the picture looks like this. You've got this unified DevOps team that routinely is shipping smaller bits of code through automated pipelines to the system. The process looks very different. And for this to work, to have a unified DevOps team, you've got to have cultural change. And this is the hardest part. Putting in new software is straightforward. Changing people is tough, especially when the people involved are as different as developers and IT pros. Because, come on, developers love change, right? Those of you who are devs, most of you, you love change. You love new things. But the people who do ops, they hate change. They love stability for good reasons. It's their job to keep things running. There's inherent conflict there. So one must create a team that prioritizes current code in production. Some mix of those things. Big changes. So what's the default reset for DevOps? The idea is that all new app dev uses DevOps. That's the idea. How do you implement that? Tool change, right? Deploy tools, continuous delivery, such as what I just showed you with ARM, and conceivably, almost certainly, change your process. Infusion changes people. So how do you change people to make this work? Well, here's one point. One point is to change the culture, and all of you devs, all of us who are devs, we have to stop seeing ops people as second-class citizens. It's really hard, isn't it? It's really hard. I mean, come on, the truth is that we see them that way, don't we? And it's wrong. We just have to stop. DevOps will not work as long as we think we're cool and they're not. So, we got to work on this. Another factor here is in the DevOps world, you're using tooling, you're automating infrastructure deployment, infrastructure as code. That means that ops people have to learn to code at some level. Well, devs can help them. That same cycle again, explore, train, use, mentor. Devs can help them do this. We've got to make actual cultural behavioral changes to infuse this idea and implementation into organizations. If you don't do this, what happens? Well, you'll provide less business value. You, with this weighty responsibility, remember, will provide less business value than you could if you didn't adopt this. You also personally won't be current. You won't know how to do DevOps, and what does that mean? It means you'll limit your career. Right? You know, there are good reasons to make these changes for your organization, for the folks who pay you. But there are even better reasons to make them for your own career, for yourself. And you know, speaking of careers, a little aside here. I don't know what your career goal is, but just for a moment, open your mind and think about what it might be. Because traditionally, organizations look something like this. There's a CEO, there's the IT organization with developers, there's business units run by, let's call them VPs. They've got business leaders, maybe their own developers over there. Great. Organizations. In this world, CEOs, the folks who run companies, virtually always come from the right-hand side. They're business people. Because in MBA speak, the stuff on the right are line functions. They're the things that create value. They're manufacturing, they're marketing. The money comes from the line side. The IT guys, well, they're a support function. They're a cost center, right? And so a CEO could never arise from a support function that's a cost center. It just doesn't happen that way. But the overall message of my talk this afternoon is, in fact, that software is becoming so fundamental, digital transformation, that it is no longer just a support function. It is a line function. So why the heck couldn't CEOs arise from IT? In organizations where software provides a core part of the value, think of automotive, where cars drive themselves in a few years. Wouldn't you like a CEO who knows about software? I sure would. I think it's entirely reasonable that someone in this room is CEO of a non-technology company. I don't mean you're a CEO of a software company. I mean a company that's in automotive or something else for which software is critical. There's no reason why you couldn't aspire to that. So, think about that. Last default reset, open source. All right. So, Microsoft, at this event, has talked a lot about open source, haven't they? They've talked a lot. Linux and all this stuff. Do you believe them? Do you think they're serious? I mean, come on. Steve Ballmer said open source is a cancer, right? Do you believe them? Well, I'll tell you, I was cynical for quite a while, but today, I believe them. And I'm going to show you why I believe them, okay? Here's why I believe them. It's about money. Traditionally, in the software industry, the vendor ships some software to a customer who then gives the vendor a big check, a license fee. That's the model. The problem with this model is that open source threatens the revenue. Open source deeply threatens the vendor's revenue. When Ballmer said open source is a cancer, what he really may have meant is it's a cancer on Microsoft's profit margins, right? Because it was. But remember our first default, the cloud is the future. In the cloud, this looks totally different. In the cloud, the software runs at the vendor. The customer gets a service which they pay for by the month, typically. Here, using open source in the vendor side in no way threatens the revenue of the vendor. In fact, the more you can use over there, the more services you can provide, the more money they will make. In other words, Microsoft's embrace of open source in Azure is a way for them to make more money. I believe Microsoft is serious about this because I always trust Microsoft to do those things that will maximize their revenue. Don't you? Right? They're serious. So, this is about money. You know, cloud computing came along just in time to save the software industry from open source. There'd be no margins left if not for cloud computing. So, Microsoft is serious here. On Azure today, they support Linux and Windows. On Linux, they support a variety of open source technologies like Hadoop and Spark, and lots of things that were otherwise Windows-based now run on Linux. Service Fabric, SQL Server, PowerShell, lots of things. On the Windows side, they support classic open source things like Puppet and Chef. Even the parts that are Microsoft-specific have open source components, like Python and App Service, and MongoDB API support on DocDB, and R in Azure ML. So, the truth, I think, is this. The war is over. Microsoft has clearly embraced open source. In fact, the distinction's fading. It's really unclear in a cloud-oriented world where you're not paying software licensing fees what open source even means anymore. It's really unclear. And so, you now have lots more options. It's fair to say that open source technologies today are Microsoft technologies in so many ways. There's no clear line anymore. And so when you make choices, you've got problems like this. Here's an example. Suppose you've got some data stored in Azure Data Lake Store. If you've not seen this, it's kind of like blobs. It's essentially HDFS as a service in the cloud, meant for big data. You've got some petabytes of data in there you want to process. There are two big choices for how you do it on Azure. One of them is HD Insight. HD Insight implements Hadoop, and more than that, but it's based on Hadoop. So you've got to create a cluster of VMs. Then you might create a Hive query to access the data. That's one approach you could take. You could also do this. You could instead process it using Azure Data Lake Analytics. Here, life's a bit simpler. You build a query in this language called USQL, Microsoft defined, that's straightforward. It kind of mixes SQL and C#. You need not mess around creating a cluster or things like that. Just run your query, get the result back. Which one should you choose? Well, there's a variety of factors here. It might be the case that using USQL is simpler and cheaper. It might be. But it's Azure only. If you use HD Insight, you got to deal with a cluster, but it's open source. And so when you're making those decisions, there's things to consider. What's best for your app? What's the best technical solution? What's the lowest cost? Least expensive is always a factor now in building cloud applications. But there's also the choice about what's best for your organization. If you build an app that uses USQL, that app will run on Azure. If you build an app that uses HD Insight, Hive, Hadoop, it'll run on Amazon and Google as well. The app is portable, or at least more portable. Is that worth considering? Maybe. Maybe. Or how about this? What about your own skills? What's best for your career? Learning a Microsoft technology like USQL, learning an open source technology like Hive and Hadoop. There are more choices. There are more issues to consider here when you're picking things. So what's the default? The idea of this new default, I would suggest, is this. All new projects should consider open source options. I'm in no way saying you should stop using Microsoft technologies. Heck no. In fact, I think there's a lot to be said for staying in the integrated, well-thought-out Microsoft world. But I think all new projects should at least consider open source, especially on Azure. And what does that mean? It means use the technologies. Spark, Node, it means use open source tools for DevOps, Jenkins, for example, if you like. And what is the actual infusion? What does changing your behavior mean? Again, explore, train, use, mentor in these new technologies. And also, it means this. Stop thinking of yourself as solely a Windows developer. And I got to stop right here, because think what just happened. This is the closing keynote for a Microsoft conference. And I just told you to stop thinking of yourself, potentially, as solely a Windows developer. I don't work for Microsoft, but do you think they would let me say that if it wasn't true? Trust me, they wouldn't, okay? So, it's a new world. It's really a new world. If you don't follow this default reset, what happens? You miss great technologies. Spark is very cool. Node can be very useful. Your technical skills will get less transferable across the cloud platforms, for example, as we see the rise of the dominant players here take over this market. And, of course, you limit your career. Bottom line for all these, if you don't do default resets, you limit your career. Some final thoughts. The new defaults, let's summarize them. All new apps are cloud apps. All new app dev uses DevOps. All new projects consider open source options. In terms of your skills, you have what I want to call yesterday skills, some of you. Windows, VB6, COM, waterfall development. Now you may still make lots of money off those, but there are very few new projects today that use all those skills. There are the today skills, Windows, C#, JavaScript, .NET, Agile, SQL Server, the today skills. What I've been talking about here, not for all of you, but for many of you, are tomorrow skills. They're things like Windows and Linux, add Hive, for example, open source languages, Azure App Service, DocumentDB, DevOps. Resetting your defaults means moving toward these tomorrow skills. Many of you are already there, many of you are not, but it means moving your organizations as well, not just you. That's what default resets mean in this context, moving toward tomorrow skills. Almost done. I want to end by just reminding you of what we do and of this, that every era has a defining technology, doesn't it? If you look back, in 1800 it was steam power. By 1880 it was electricity. By 1925 it was engines, cars. Today, is it not transparently obvious that the defining technology is IT? Clearly. It's also obvious that innovators in an era's defining technology are the people who create the future. Who are those people? It's us. It's us. My last thought, which I believe with all of my heart, is this. We work in the most important profession in the world. Thank you.
Thank you so much, David. Thank you so much. This was Tech Days 2016. Wish you all safe home and see you next time. Thank you.